All right, so I want to make sure to respect everybody's time here. So I am going to go ahead and get started. This is recorded so that if anybody needs to sort of go back later and watch from the beginning, if you're joining us a little bit later, you'll be able to do that. So the plan for this session is really just to kind of go through and keep doing problems like we were doing in class, highlighting, each problem teaches us a different kind of skill, if you will, a different kind of strategy for solving unit conversion problems. So I'm going to ask Courtney and Daniel, you guys, if there's anything from the problems that we worked on already in class the past couple of days that you want me to explain again. Again, this is the perfect time to kind of do this. We're sort of open-ended. We don't have time restrictions. So, I'll take a half an hour on one problem if that's what we need to get people kind of up to speed. Oh, and you're muted, Courtney, so I can't hear you.
I was talking to Dan, who's right next to me.
Oh, all right. So yes, we might need to make sure that we don't have both of you having your microphones off. So, and if one of the things that works really well is kind of putting information in the chat. So one of the things that sort of worked well was, and this is how I came up with the strategy with the cards to use in person, is I would have people reply in the chat when they were done or ready. And that's how I'll monitor the chat as you guys work through problems. So welcome, Sarah. So I was just sort of asking Daniel and Courtney, was there anything you wanted me to go over from the problems that we worked on, either in today's class or in Friday's class? And if not, we'll go ahead and we can start, just keep working on new problems. So Dan, and with a small group like this, I usually do call on people individually and just kind of ask you guys to give some feedback. So Daniel, is there anything you wanted me to go over from either today's class or Friday's class, the problems that we did?
No, I think I'm good. I'm ready for new stuff, I think.
Okay, how about you, Courtney? If you want, if we're having feedback and stuff, you can always use the chat to reply for things.
Does it echo for you?
Go ahead.
I just get confused on like where to start.
So, and I think one of the things that's helpful is the more problems you do, the more that starts to kind of crystallize and become more clear. I won't say that it becomes completely clear, but it becomes clearer. So hopefully it's just a matter of we keep practicing. And how about you, Sarah? You may need, I can't hear anything, so I don't know if you're able to unmute.
Sorry, can you hear me now?
I can.
Okay, so I've gone through a lot of the problems and had no issues with a lot of them, but I'm still kind of confused on the one we went over in class today. And I actually sent you an email about it because I feel like I really need to understand where my thinking went wrong. And that's where I converted micrometers directly to millimeters instead of bridging to like meters and then back to millimeters.
Yep. And was this the one where you talking to me in class about it? We were kind of like, I wasn't up by you, but you were saying, yeah, I got the right answer, but I didn't have the same sort of stuff.
Yeah, and I actually emailed you my math because I was like, I really need to know where my thinking's wrong here so I don't make the same mistake.
So I'll take a look at this and it might be something that maybe when we're all done here, if you can stick around a little bit at the end, we can kind of go over that. Or maybe as we go through some more problems today, you might find something that allows you to figure that out. But if everybody else seems okay, what we'll do is we'll just start doing some more problems. And I'm going to run this the same way that we did problems in class. So here is another problem. So we're talking, and there's an A part and a B part. So it says a small hole in the wing of a space shuttle requires a 20.7 cubic centimeter patch. So now we're talking about an area. So we want to convert that patch's area into square kilometers. And I love hate this problem because there's nothing practical about this. Like if we've got a patch that's about, and if you think about 20 centimeters squared, that's maybe like 4 centimeters by 5 centimeters. So it's like this big. And I'm saying, let's make this into units of square kilometers. Like there's no logic to this. It's just an exercise in making sure we can do these kinds of unit conversions. The second part is a little bit more reasonable. It says, hey, if the patching material costs $3.25 per square inch, what is it going to cost us for this patch? So work through both of those. And what I'll have you guys do in the chat is you can just type in the chat. You can say, you know, part A, you can either say done or ready. And then part B, you can say done or ready. And so what we did last year, and the students, I got really good feedback, they said it worked well, is you guys just get some time to work on these. And then I'll just kind of hang out until I see that everybody has said either done or ready, and then we'll walk through the solution. Okay. And especially with a small group, don't hesitate. If you want, you can sort of unmute and maybe, you know, ask for some clarifying questions, but I want to give you guys an opportunity to sort of work on your own. So I'll be here, but I'm going to mute my video and my mic.
Okay, I'm done.
All right, perfect. I think that was Sarah. So if you guys want, when you are done, just put in the chat, say, part A ready, part B ready. If you need, some help, you're getting stuck, you're not quite sure what to do, or you can say done. Okay, so ready for part A. So I'm going to wait because I think my answers for these, actually I have them on separate pages. So we can go through part A if we want. So it looks like ready means you didn't get the answer and you got stuck. So am I reading what you guys wrote there when you say you're ready? Okay. All right. So let's go ahead and we'll go through part A and then we can do part B. Now, one of the challenges, and this is why, there's this balance between me giving you guys time to work on problems on your own versus me just showing you an answer or walking you through the answer, is there's always this disconnect. It's almost like coaching or anything like that, where it's like, if you're constantly doing things with the coach and, it makes sense when the coach does it with me or when the teacher does it with me. That's not how the quizzes and the exams are. So we want to make sure that we get to a point where you're able to have more confidence kind of doing things on your own. So let's walk through this. And just like we did in class, I have the entire solution kind of put up here. So on your computer, it might be something where you could easily do like a screen capture or something like that. So you have the solution, but you might be well served kind of just making sure you could listen as I'm going through so you can hear the explanation. So for this problem, okay, and I'm going to zoom in here just to kind of show you. This problem was asking us, they gave us the area of that patch in square centimeters, and I want to get to square kilometers. So this is one of these things, especially if you're getting confused early on, what I want you to do is write a roadmap. Okay, roadmaps are something that will get you partial credit on exams if they are the correct roadmap. Maybe you didn't put the right pieces in, but always start with a piece of information that's given to you in the problem. And right now I'm not putting values or numbers in, I'm just putting units because I know I started with cubic centimeters and I want to get to cubic kilometers. Now, I'm sorry, I shouldn't say cubic. We were doing cubics before. This is square. This is square centimeters to square kilometers. Okay. Now what I need to do is say, all right, do I have pieces that connect together such that I can walk from centimeters to meters to kilometers? Or, ultimately centimeters squared to meters squared to kilometers squared. So one of the things that I'm recognizing here is I've got meters all the way through here. So all I'm doing are some prefix conversions, right? And these are things that you need to know, okay? So in my mind, and again, I'm not doing any calculating yet, I'm just kind of doing some planning, making my roadmap. I know the relationship between centimeters to meters is a factor of 100. There's 100 centimeters in 1 meter. I also know a relationship between meters to kilometers. Okay, it's going to be a factor of 1,000. Those are those prefix conversions that I need to know. Okay, so once I've got my roadmap laid out, I know information that I'm starting with, I know where I want to get to, and I know the pieces that are going to allow me to take one step at a time and get there. Now I'm ready to actually put that into a calculation. Okay, so I'm going to pause for a second there, and I'm going to ask you guys to kind of, if you need clarification on this, this is for those of you who are struggling and saying, I don't know where to start or how to start these problems. You need to have a roadmap that starts with information that's given in the problem. The problem will always tell you where you want to go, right? Because this problem says, what is the patch's area in square kilometers? So I need to have an answer that has square kilometers. That's how I knew I needed to go there. Okay. And then I need to ask myself, if I started with centimeters and I need to go to kilometers, what are relationships that can allow me to connect those pieces together and go there? So I'm going to pause for a second and see if anybody needs any more clarification on the setup part of this. All right, so if you don't unmute or I don't see anything in the chat, we're going to keep on keep on going here. Okay, so now I have my roadmap. I need to put those pieces together. Okay, so, and right here, I'm kind of highlighting that I really don't know one step to relate centimeters to kilometers. I will tell you the problem that you're going to have in class is not going to be a single step unit conversion. It's not even going to be a 2-step. It'll be 3 or 4 unit conversion calculation pieces that you need to put together. Okay, so we want to make sure that we can see sort of these relationships. Okay, so this is where sort of the map, the rubber hits the road, if you will, in our map. I'm going to take the map and I'm going to put the pieces in. So I started with centimeters squared, right? And now I want centimeters to go away, and I know a relationship between centimeters and meters. So this is where some people were getting confused when we were doing stuff in class today. What I have in parentheses here is the relationship that I know. There's 1 meter, or I should say there's 100 centimeters in 1 meter, right? Now, some people were doing things where they're like, hey, can I put the 1 down with my centimeters? Absolutely. But then it's going to be 10 to the -2 up here for my meters. I find that personally a little bit harder to think about. So I always like to have the 1 with my bigger unit. So we talked about this last time. We've got sort of this big little relationship. Okay. You're always going to have 2 units and 2 values. Okay. So what you're going to have is the bigger unit. It's one of her teeth. Oh, sorry. Our puppy is losing her teeth. So we actually have one. You want to say hi to everybody? You can say hi. That's my husband.
Make it a necklace.
You're gonna make a necklace out of Charlotte's teeth. That's really kind of gross, but well, now where did she lose that one? Just
Porch.
Just fell out.
it just fell out. She spit it out.
No, it just fell out.
Just fell out of her mouth. Sorry, guys. Day in the life of the Parenti household is the puppy losing teeth. All right. So I want you to remember this big little combination, because this is another place where students can easily make mistakes. You might know that there's a 1 and a 100 that go in the relationship between meters and centimeters, but you have to make sure that the right pieces go together. So always think about a big little relationship. Hopefully everybody knows that a meter is bigger than a centimeter, right? So if the big value is up here, I want that to go with the little number. The little unit gets the bigger number. So that's a classic place that students can kind of make some mistakes, is they don't have the matchup of the correct units there with the value. Another place that people made mistakes, and I saw a lot of this today when I was walking around, is they would just put the 2 right there. Okay, we want to make sure that we do that, because that we don't do that, because when we square this quantity, so the relationship is 1 meter equals 100 centimeters. We need to square the entire quantity. That's why I have this in big parentheses, which means I need to square not only the unit, but the value. Okay, so in order to make this into 1 meter squared on top, it's actually going to be 10,000 cubic, I shouldn't say cubic, I keep saying cubic because we did cubes today, square centimeters on the bottom. Apologies if I've been saying cubed here. This is square. Okay, so that's 2 common places that people make mistakes, is they don't have the big little relationship. And then when you need to have a unit be squared, you have to make sure that you take that square and distribute it to the unit and the value. Okay, now if you haven't picked up on this yet, this is how unit conversion works. The big picture is, because these 2 things are equal to one another, I'm essentially multiplying my original patch size by a value of 1. That means I'm not changing the size of my patch. I'm just changing the units that I'm thinking about the size of my patch in. When you want to change units, you take something that's in the numerator and you make it go away by putting that value in the denominator. So sometimes people can get confused when you're putting this piece in. Which way do I put it, right? Well, I want centimeters squared to be in the denominator, so it cancels with this centimeter squared. So that's how we're going to set these up. Okay, so I really want to encourage you to kind of be able to follow what I'm doing. for me to be able to follow what you're doing for partial credit, set up your unit conversions such that you're always multiplying by, and remember, we talked about this, this is a relationship value. It's got something in the numerator and the denominator. You might have something that are just single values, right? That's not a relationship. Usually the information that's given to you in a problem will often have at least one piece that's just a single quantity. It's not a relationship value, okay? Multiplying by that first piece is going to get us to units of square centimeters, or square meters, excuse me. And now I know my relationship between meters and kilometers. 1 kilometer has 1,000 meters. Always do a logic check if you happen to be somebody who kind of mixes these up and confuses these. All right, I know what a kilometer is. Like I can run a 5K race, and I know what a meter is. A meter is like about this big. So if you said that 1,000 kilometers contained 1 meter, that wouldn't make sense, right? So we want to make sure that we do logic checks all the time with these problems. Okay. So when we run through this problem, so another thing, and Sarah, this could be part of where things can kind of get messy with students. And I kind of have this as a reminder to myself to highlight to people. When you're putting things in your calculator, okay, and I think I went through this and kind of showed people. I'm going to show you because I can kind of hold it up here. So with this calculator, this is the calculator that I encourage people to get if you were looking for a calculator. There's a little button there that says EE, okay? I want you to use that when you're doing scientific notation. Sometimes people get in the habit of they type 1 and then they use the multiplication times and then they say 10 and then they use this little caret symbol. And if you're doing that, please get away from that for a couple of reasons. The first is it takes a long time to do that. The second is it's not uncommon for people to make mistakes, particularly when you'll see something like this, right? This guy is going to be 10 to the third. What sometimes people will do is they'll say 10 EE3, and they're like, I put in 10 to the third. But really what you just put in was 10 times 10 to the third, which is really 10 to the fourth. Okay, it's going to be a different value. So I've said a lot right here, and I think everybody here sort of said that they were ready, which means you didn't quite get the answer to the problem. So I'm going to call on you guys one by one, and I want to hear maybe where you got stuck. And that's really helpful when people are watching these videos later to sort of learn. So Daniel, you're at the kind of the top of my list here. So I think you had said ready. So did you get the problem or did you get stuck? Tell me where you got stuck.
I got stuck, but it was like halfway through the problem.
Okay, so where did you get stuck?
On the multiplication, kind of.
Okay, so one of the things that we want to make sure we do as well, and if you need to, please go back, and I know it was a long video to watch on that unit conversion sort of video, that Edpuzzle video. You can always rewatch them outside of Edpuzzle, just on YouTube. There's a lot of little nuggets that are in there. And one of the things that sometimes can be problematic for students is when they're putting things in their calculator. If you in your calculator were to say 20.7 times 1 divided by 100 squared times 1,000 squared. If you don't put things in parentheses, depending on the calculator that you have, you can get the wrong answer. So sometimes what I'll do with students is I'll say, let's make sure that we just multiply everything that's in the numerator all the way across, get that value. Multiply everything in the denominator all the way across, get that value, and then divide your numerator by your denominator. So, if you need to take some of these extra steps, if you will, early on, I encourage you to do that to make sure that we don't kind of take some shortcuts that end up giving us the wrong answer. So Daniel, anything else that you maybe wanted to ask about or comment on before I move on?
No, I think I'm okay.
Okay, Courtney, how about you?
So I once you started explaining it, I kind of understand where to go after that. It's just
Okay.
starting the whole thing. But when I type it into my calculator, I'm getting the 2.07, but I'm getting 10 to the negative 10th.
Okay, so you're off somehow by a factor of, so, and it could be, so if Daniel's there with you and he can help you look at your calculator, make sure that when you're kind of typing in these things that we're not doing one of these things like I highlighted at the bottom, where you're actually off by a factor of 10 because how you're entering it in your calculator. So I'll come back to you guys in a minute because Daniel's right next to you, right? You guys are,
Yeah.
okay, so if you maybe can kind of take a look and see what she's doing, because that is a very common mistake that students will be off by a factor of 10, and it's usually because of how they're entering things into the calculator. How about Sarah S?
Oh, I got them both right.
Oh, good. Okay, Brooke. Brooke, I can't hear if you're muted. And if you need to, you can type something in the chat. Oh, you might be, I think maybe you're okay now. You're unmuted, but I still can't hear you. All right, Brooke, I'm going to come back to you. Allie.
Can you hear me?
Yes, I can.
I think the part I was getting stuck on was when it's like centimeters squared to remember to multiply it, but I think I have a better understanding now.
So it's one of those things, like the first time you see that, it's easy to forget it and not do it, but then it's like, it can be confusing as to why, but the more problems you do something, I mean, the first time you do a problem, it's difficult to get right, but it's that repetition and repeating that kind of a skill that you're like, okay, now I know what I'm doing. If I need to square a unit in a relationship, that means I need to square not only the unit, but the value associated with it. So that's why those are in parentheses. Maggie, how about you?
I came in right when you guys finished, so I haven't done it yet.
Not a problem. So yeah, how these problems will work is it's very much like we'll do in class, but it's a much easier mechanism, and usually it's a smaller group than we have when we have everybody in class, but I usually call on people, and students in the past have said it's really helpful when they hear, oh, somebody's making the same mistake that I did, or they'll learn something just from someone else's mistake that maybe they hadn't been thinking about that. All right, Brooke, I'm going to come back and see if I can just figure out if we can hear you.
I have a question.
Yes, go ahead. Who is that, Daniel?
Can you zoom out so I can take a picture of it?
Yes. There you go.
Can you zoom out a tiny bit more?
All right, sometimes what happens, yeah, is it's things get covered by things in on the computer. Is that good enough?
Though, thank you.
Yep. All right, Brooke, I want to see if we can figure out how to hear you.
Can you hear me now?
Now I can hear you, yes.
Okay. I think I'm okay. I joined sort of in the middle, but looking at your work, I think it's making sense. So
okay. So we hadn't gone through part B. So why don't you guys try to work through part B? I think a couple of you maybe have finished part B already, but try to work on part B. Again, use the chat function as a way to just say, and I'm going to look at this point on, say ready if you are like, I'm stuck, I'm ready to go through the solution, or say done if you get the answer. And just kind of, I'm going to circle back real quickly to this first page. The answer that you should get is that the patching material will cost $10.43. Okay, so I'm going to mute myself here just for a couple minutes, give you guys a minute to work, and then let me know in the chat when you're ready.
I'm done.
keep in mind too, as you're working through problems here tonight, that there are certain things like the prefix conversions that I expect you to know. But if you need one of those English to metric conversions, please feel free to refer to, you know, the handouts, your notes, whatever, because those will be provided for you.
Where do we find like the handouts on Blackboard?
Really good question. So let me, I think I can actually go here. I'm going to go keep working, those of you who are working. And let me go, I think I can find them on Blackboard here to show you. So on Blackboard, if you go under learning units, and for example, if we're under unit 1 here, so these in red are the 2 Edpuzzle videos that you'd watch, but these PDFs that are underneath, these are the things that have all my notes and all of these problems. So for example, if we look at this one here for unit conversions, if you click on it, you'll see that it's basically my notes that accompany the videos that you guys watch. And you'll see usually any important figures that are part of those videos. So here you can see there's the table that has the prefixes. Here's the piece here with English to metric conversions. And then all of the problems that we're working through, these problems that we're practicing in class and so forth, are always listed at the end here. Any ones that have an asterisk next to them. So if you can see here that there's an asterisk that we have right there, that's going to be something that has a video solution that's worked on Blackboard. So let me go back to Blackboard here just for a second and just show you, because somebody had asked today too, so this is a good opportunity just to highlight. There's a lot that's in each learning unit folder. It's not necessarily meant to be something you have to look at everything. This first little video here, it's a little 2-minute video. It's like if you want to get the 30,000 foot view of what this skill is about or what this learning unit is about, it just kind of gives a real brief overview. All these videos that are at the bottom here, okay, these are ones that are those asterisked problems. So for example, let me come and we can see that there's some of these problems that are listed here that have asterisks next to them. Okay, this is a little bit, it's lagging a little bit. There we go. So these ones here, do you see how it says like sample problem 1.8? So problem 3 has in parentheses sample problem 1.8 at the end. So if you wanted to try this problem on your own and you wanted to see an answer key, okay, you can see that on Blackboard. So we could come over to here and we can see that there's the second one down there is sample problem 1.8. So there's a PDF copy. So if I click on that, that'll actually show me a worked out sort of solution. It'll show me the answers for that. But if I wanted to actually watch a video that shows how to solve that problem, I can come here and I can find sample problem 1.8. So if you were to click on that video, you could actually see me work through the solution that actually resulted in that end problem. So I know that was a lot more than you probably asked for, but I think that was a good opportunity. That problem came up. I should have my video on here so I can be chatting with you guys. Came up at the end of class. And so it was an opportunity to kind of highlight all of that.
Thank you.
You're welcome. All right, how are the rest of you guys doing? So I'm seeing a few people said done. So remember, use the chat. Let me know if you're ready or if you're done. Done means you got the right answer. Let me come back here to our problem. So let's see, we've heard from Maggie, Sarah, and Courtney. So Allie, Brooke, and Dan. Oh, I think Dan left. I heard somebody had left. So Allie and Brooke, do you guys still need some more time? Or are you ready to go through the solution? All right, I don't know. I can't hear if you guys are saying something. But I'm just going to go through. Oh, Brooke says she's ready. Okay. Oh, both of them are ready. Good. Yep. Use the chat. So just reminding it. So ready means you're like, I didn't get the right answer. So let's go through it so I can sort of see things. All right. So I'm going to do the same thing with this problem. I'm going to kind of zoom in here and go through the different parts of this because the solution is all there at once. So information that's given is I know the number of square centimeters. Sorry, I'm stuck in volume. Square centimeters. I know the size of that patch in square centimeters. And my question is asking me, how much does it cost? Now, unless I know something that allows me to directly connect those. So again, this is one of those things. How do I know I have something that directly connects them? I have a unit conversion that says this number of centimeters squared equals this dollar amount. Unless you have that relationship, I don't have a one-step problem. But here's what I do have, right? I do have the fact that if I want to get to dollar amounts, I'm going to actually take this roadmap and go in the reverse. I know a relationship between centimeters and inches, right? That's an English to metric conversion. That's given, right? So 1 inch is 2.54 centimeters. So I know I can walk from square centimeters to square inches using this relationship, okay? And a piece of information that's given in the problem is the relationship between dollars and square inches. Now, it wasn't dollars and square centimeters, but now I've got my last bridge that allows me to walk to dollars. So this one is actually only a two-step problem. Start with information that I know. I know that my patch is 20.7 square centimeters. This is just like we've been doing here. I put my relationship in brackets and then I square the entire thing, which means the units get squared, but so do the values. So I have to remember when I'm putting this in my calculator, I have to have two 2.54s in my denominator, okay? So the math that you'll put into your calculator is 20.7 times 3.25 divided by 2.54 squared. If you go ahead and do that, you should get 10.43. Okay, so I'm going to kind of just reach out to you guys. I think Sarah and Maggie and Courtney, you guys all said done, so you were able to get the right answer. So Allie and Brooke, I'm going to start with you, Allie. Where did you get stuck? Let me try to kind of help you work through any spots where you got stuck.
I think I was making the problem too complicated. I had like 4 steps.
Okay. So
I
tell me
didn't
the
need
steps
more.
that you had. And again, this is always very useful because I guarantee there's somebody else who was sort of doing the same thing. So what were the steps that you had?
Well, somehow I accidentally started backwards and I started with the 3.25.
Okay. So I'm glad you brought that up. That's not a problem to start with that. Okay. Now, one of the things we have to make sure we do is if you start with something that's a relationship quantity, we know we want to have units of dollars in our final answer, right? You with me on that?
Yeah.
Okay. So that means we need to have the 3.25 in my numerator. Because remember, anything that's a relationship, you could use it in either orientation. So starting with it this way, and we're going to see that with another problem we're going to work on, we have to make sure that we start with our units in the right spots. Otherwise, we'll end up with the reciprocal of the answer that we want, right? Because if dollar sign is in the denominator, that's not going to be the right answer. So you can start with this piece. And then I could then multiply, I could put 1 inch over 2.54 centimeters, right? And then I could square that entire quantity. So I could essentially work backwards. But if you said you had 4 steps, I want to know what were the other steps you had.
Well, so once I had 2.54 centimeters to 1 inch, but then for some reason I was converting my centimeters into meters. I don't know why. And then I was just going on from there.
That's not uncommon, especially now. I think if you have a roadmap, like if I have this roadmap, that stops me from kind of taking a detour that's non-productive, right? If I know that I can walk from centimeters to inches and then from inches to dollar signs, that stops me from doing unnecessary unit conversions. And one of the things that's always hard for me when I give partial credit for things is, Dr. Brown and I, we've been teaching Gen Chem for a long time. We always have the same rule with partial credit. We give partial credit for steps that demonstrate forward progress to the solution. So even though you may correctly convert square centimeters to square meters, because that doesn't help us with the problem, it's not anything I can give partial credit for. So sometimes it's really hard when students have these beautiful things, but it's a roadmap that takes them not in any direction towards the solution. So, but it's good. The more of these you do, I think you just recognize patterns and how to do things. Let's see. So that was, I think, Allie that I just talked to. So Brooke, how about you?
Sort of the same thing that Ali said. I was making it more complicated, and I was like using the answer from part A when
Okay.
it was much simpler this way.
Got it. Okay, and so Allie, maybe that's part of what you were doing too, is if you were starting from part A, okay, and don't necessarily always assume that when we have multi-part problems that they build on one another. That's not always necessarily the case. We did a problem in class today where we actually could have started with the original data, or you could have started with the part A problem. Now, you could actually do this, but in this case, you're going to have to go, then it is sort of a 4-part problem, because you'd go from kilometers to meters to centimeters to inches to dollar sign. So you absolutely can do that, but that's more work than is necessary. But maybe, Allie, if that's what you were doing, that makes sense why there was four steps if you were starting from part A.
Yeah, that's how I started. I started with the 2.09 times 10 to the negative 9.
Got it. And totally correct to do that. There's nothing incorrect about what you did. It's just more steps. But this is why I love going through these problems like this, because I always learn new ways that students think about doing things, or you'll realize that, hey, it's not wrong that I did that. It just was more work. Any other comments, questions on this problem? Okay, so let's keep going, right? So you need to paint a wall that has an area of 36 square meters. The paint you are using claims that 1 gallon covers 400 square feet. How many 1 gallon cans of paint will you need to completely paint the wall according to that claim? Okay, so remember, I have intentionally chosen all of these problems that we work through because each one of them teaches us like a little subtlety or nuance. So see if you can work through this problem and get that you would need to purchase 1 can of paint. Okay, so I'll give you guys a few minutes here. Let me know in the chat when you're ready or done. All right, I think that's everyone. And we have a number of dones and then one ready here. So let's go through the solution, and then Courtney, I might just ask you where you got stuck and how I can help you here. Okay, so here's the solution. Let me zoom in. I always like to, in a few of the problems that we're going to work on tonight, I'll have a picture, because sometimes I feel like I can wrap my brain around all of the words and numbers that are in the paragraph if I can see a picture. So here's my little wall. It's got an area of 36 square meters, right? And here's information that's given to me, right? Before I look at the solution, I know that 1 gallon will cover 400 square feet. So that's an equality piece, right? 1 gallon equals 400 square feet. Sometimes one of the things you're going to need to do when the problem is given to you as a word problem is recognize how words are telling us equalities. They're telling us these relationship unit conversion pieces. So 1 gallon equals 400 square feet. I want to know, the question prompt says, how many gallons of paint do I need? Okay. So 1 gallon cans of paint. So I know that 1 can is a gallon. So if I know how many gallons I need, I can figure out how many cans I need. So here's my roadmap. Okay. My roadmap says, I know how many meters squared my wall is. I can use an English to metric conversion to tell me how many square feet that wall is. This is the bridge that's going to allow me to go between feet and gallons. So this is one of these pieces. It's really important. If you find yourself getting stuck, if I want to change the units, I need to find an equality that relates those units. So because I have an equality that relates feet squared to gallons, that can allow me to change from feet squared to gallons. And then because I know that 1 gallon is in each can, that can allow me to relate to the number of cans. So here's the walkthrough for the problem. And again, my walkthrough mirrors my map. So 36 square meters, 1 meter is 3.28 feet. Just like we've been doing for lots of problems, I have to make sure I square this quantity. Now I can have my relationship that allows me to walk between square feet and gallons. And then lastly, if I stop the problem right there, I would know how many gallons I need. In this case, there's nothing mathematically that's being changed here by this unit conversion, but a lot of times I'm going to be doing things that puts those pieces in because it allows me to make sure my units cancel. Now I know that there's 1 gallon in every can, so this will give me answers of how many cans I need. So the answer is that I need 0.9682 cans of paint. So here's one of these pieces where we end up having to do a little bit of a logic, right? Can you go to Lowe's and purchase 0.9682 cans of paint? No, you can't. You have to purchase whole cans. So in this case, the answer needs to be rounded up to the nearest whole number. Anytime we're doing something where we're counting, we need to round up to whole numbers to count. And this is just a reminder, when you're providing answers, it's not going to be relevant for the quiz on Wednesday because you're just providing an answer via Blackboard. But if you're doing things where we're turning in problems on an exam or whatever that happens to be, I want you to box your answer so I can easily find it, and then make sure that your units and your significant figures are correct for your answer. Okay, so just as a little, and this is like one of those logic things that we should know. Let's imagine that we didn't have 36 square meters. What if we had like 50 square meters? And I think the math will work out here. If we had 50 square meters, this is going to be just slightly more than 1 can. Okay. Now, I can't go to Lowe's and buy 1 can of paint because I'm not going to have enough to finish it. So even though I only need a tiny bit more than 1 can, I need to round up to the nearest whole number. I would not round down there because then I'm going to run out of paint. So hopefully that makes sense. If you have a problem where you have to do counting, okay, you need to make sure that you round up. So that's that problem. Let me just kind of look through here. So Courtney, I'm going to put you on the spot here if you don't mind. You had said ready. So where did you get stuck with this problem?
So like I knew like where I had to go with the problem, but I got stuck at like knowing like the 3.28 feet over 1 meter,
Okay.
trying to figure that out.
So, and that's something I would not expect you to know that. You're always going to have access either to that table of English metric conversions, or I will provide in the English to metric conversions that you need as part of the question prompt. So that's one piece that, that would be given to you. Anybody else have any questions on this problem? Anything else you want me to, go ahead.
Sorry, I put 1 foot, like for the second part, I put 1 foot on top and then 0.30, whatever it was,
Totally
on the
fine,
bottom.
right?
And I got
Yes.
like a little bit of a different number. Is that
So,
okay?
that's
It was
okay.
still 0.9675.
And that's just a matter of those English to metric conversions. They only have 3 sig figs with them. And so depending on how you round them, they're slightly different depending on
Okay.
which unit has the 1 with it. Because it's not a prefix conversion, that's, an exact number. So, and
Okay.
that's totally fine. And I get that. And, that would be, full credit for things.
Okay, thank you.
You're welcome. Anybody else have anything on this problem? Okay. And I was just going to make a comment that, if an hour is all that you feel like your brain can handle right now, that's fine. I'll always be here for 2 hours. You can join us 1 hour in, leave with an hour left, whatever, your mental capacity can handle with chemistry and so forth is totally fine. You don't even need to say anything to me, if you need to come or go, that's totally fine. So let's go on to another problem here. Another one where it's kind of asking us to think about a quantity of something. So it's talking about the recommended daily allowance for vitamin C is 60.0 milligrams per day. And if we know that there's 70.0 milligrams of vitamin C in every 100 grams of orange, how many 3-ounce oranges would you have to eat each week to meet this requirement? And I give you one of the important unit conversions that you'll need there, which is the conversion of ounces to grams. So 1 ounce is 28.3 grams. Okay, so take a stab at this one. And the answer is going to be that you need to eat 7 oranges in a week. Okay, so see if you can work through the solution to this guy. Sarah S., how are you coming along here? I think you might be the only one I haven't heard from yet to see if you're
Oh.
ready.
Yeah, sorry. I think I'm ready. I think I got the right answer, but I think I did the steps like in different parts. So I'd
That's
like to
okay.
see the right way to do it.
Well, and keep in mind, so as I'm going through this, whoops, I'll highlight here, that there, again, when we're multiplying things together, there's not one completely right way to do it. So again, I'll flip here. If you wanted to do a screenshot or something, go ahead and do that, but then spend some time listening so that we can kind of make sure to kind of go through so that everybody sees. So this is sort of the worked out solution. There's a lot of information that's given in this problem. And at the end of the day, the question is asking us how many oranges. So I need to know number of oranges. Okay. So one of the things when you're trying to figure out where to start with this stuff is if I want to know number of oranges, I'm going to pick a piece of information that starts with oranges in the numerator and then something else in the denominator. Okay. Because that allows me to make sure that I'm going to have the right sort of pieces here. But it's important that I'm talking about one quantity of oranges, because notice there's a lot of things that have units of orange here, but that's saying that that value and that unit belongs to an orange. It's not the number of oranges. Okay, so this problem I think is challenging because there's lots of pieces of information that are given here. So I'm going to take a second and sort of pull these out from the problem. Okay. Anytime that we have something here where it's like, hey, 60 milligrams per day is the daily allowance. So I know that 60 milligrams of vitamin C is equal to 1 day, right? That's what I get from the words there. But what that creates for me is a unit conversion here that has milligrams of vitamin C in the numerator and then day in the denominator. Keep in mind, I can actually use these in a variety of different sort of directions here. My Apple Pencil, I think, keeps dying here. Just going to check this real quick. No, it says there's plenty there. It just keeps disconnecting. Try to just reconnect it here. So another piece that we have here, 70 milligrams of vitamin C is equal to 100 grams of orange. So when we see this word per, okay, per is an indication that we've got a relationship. Okay, so as you're you're struggling with some of these problems, here's what I would do. Looking at all the words here, it's just like it's like a data vomit that we have there with all of this information that's here. So we need to figure out how to take and create unit conversions from the words that are given. Okay, let's see if this reconnected. Good, reconnected here. So we've got this unit conversion, we've got this unit conversion, and we've got this unit conversion that come from the text that's here. Okay, so now once I know all of these pieces, I need to figure out how to string these together to have units cancel and end up with the units that I want. So what I do to start this problem is it's like I need to pick something that has units of quantities of orange. The only thing that has units of quantity of orange is that 1 orange is equal to 3 ounces of orange. Okay, so that's how I choose to start this problem. So Sarah, you could actually start with any one of these, but I want to make sure that I have the units that I want for my final answer in the numerator. Okay. Now I have to find something that relates ounces of orange to something else. Okay. And here's where it's like, well, everything else doesn't have ounces of orange. It has grams of orange. Okay. This one has grams of orange. So I need to put a piece in here that allows me to change the units of mass that I'm talking about. So I can change from ounces of orange to grams of orange using an English to metric conversion. Okay, so this is one of these things that's not given in the problem, but it would be part of a table that's available. Now I'm in units, so these guys cancel. Now I'm in units of grams of orange. Okay, do I have something that makes grams of orange go away and gets me to something else? Grams of orange. Oh, okay, this unit conversion relates grams of orange to milligrams of vitamin C. Okay, so I can do this guy here. And then it's, okay, well, wait a minute. I want to know how many oranges I have to eat in a week. So I need to somehow have units of like time that have passed. And so I can say, well, I can make this go away. I want that guy to go away. I don't want milligrams of vitamin C in my answer. Oh, look at this guy. It relates milligrams of vitamin C per day. Okay. And then this would tell me that I would have to eat this many oranges per day, but the question asks me for a week. So I need to do a little unit conversion there. Okay. So this is, if you wanted, you could say I would accept 8 for this, right? But in this case, this is close enough to 7 that if you had 7 oranges per week, you'd probably meet this requirement. So there's a lot to this problem, but sort of the take-home piece is the map isn't easy to draw with this one. This is a problem where the map isn't obvious like the other one was. But what I do is I create my map as I go along, and I say, I'm going to start with a piece that has the units that I want, okay, in at least one space. And then I find pieces that I can stick in there that allow me to cancel out units that I don't want and keep walking towards something that I do. Okay, so Sarah, I might just start with you here because you said you got the right answer, but you weren't quite certain if the path that you took to get there was right. So I'll let you just kind of speak to that for a moment.
Yeah, I basically, sorry, I'm losing my voice.
That's all right.
I flip back to it because I was doing some scratch work. So basically, I did this weird thing where I figured out that I needed 420 milligrams per week. And then I converted that to 42 grams a week. And then I did a conversion of ounces to grams. And then I got that I needed 59.43 milligrams of vitamin C per 3 ounces of orange. And then did 420 milligrams divided by 59.43 milligrams to get 7.067 3 ounces of orange per week. 3 ounces orange. Yeah.
I followed your thought process, but only because I've been doing this problem for I don't know how many years. But that totally works, and I would be able to follow that. Now the challenge is if you didn't get the right answer, it might be hard for me to follow your thought process because I don't know if you had it set up with a number of unit conversions or you kind of did these little mini calculations that kind of led into one another. Right? It sounds like that may have sort of been a thing that you did in order to figure out, okay, all right, how many milligrams of vitamin C do I need to eat per week and so forth. And then you sort of connected pieces. So you did all the right calculations. But again, mapping this onto unit conversion, the idea with becoming a master at unit conversion is you can very often walk to the right answer, even though you might not understand how, if you string your unit conversions together properly. So let me come over because I think everyone else sort of said ready. So Courtney, I'm going to start up with you. So where did you get to in this problem, or where were you stuck, or were you stuck at the beginning?
So I wasn't actually stuck at the beginning this time. I got through it. But where I got stuck, I was kind of had a not really dumb blonde moment because I'm not blonde. Sorry if any of you are blonde, but I just forgot I guess I didn't fully read the question, and I just forgot to do 7 days per week.
So you got to the 1.0959.
Yes.
Good. So, and that's why, again, every one of these problems that I intentionally have chosen and used over the years teaches us another little piece of information. And usually in my keys here, I have them in red, which is hey, the quantities that we're using are really important because they've got those 3 pieces: the value, the unit, and the qualifier. So if we think about the units that are with that answer, that's oranges per day. Okay. And if we remember, wait a minute, the prompt asked me orange per week. that'll send off a little alarm bell to be like, hey, I'm not finished with the problem because the units that I came up with are not the units that it's asking for. Okay. But good news is, if this was like a 10-point problem or something like that, you'd probably get somewhere between 8 to 9 points because you got a lot of the hard stuff correct. So that's great. Brooke, how about you?
I actually got the right answer. And I started like backwards. I had the 60 milligram per day, and then I just had the day to week conversion like right in there.
Yeah. Yeah.
I accidentally put ready instead of done.
Oh, well, that's good. Well, hey, this is really great because I think you guys came to this probably because you were feeling like you were a little bit rusty or concerned about, but the more of these you practice, you just see it. This is all about kind of pattern recognition. And as I highlighted in class today, because multiplication does not have a specific order of operation, you can start with any one of these pieces. The challenge is if you started, for example, with 3 ounces of orange equals 1 orange, if you started with it in that orientation, you're going to end up having your units backwards in the denominator rather than your numerator. And that can often be something that really trips students up because they have all the right pieces, but it's like it's upside down. And so that can sometimes be one of these pieces where you're like, I thought I understood what I was doing, but that's not the right answer. And well, actually, if you took the reciprocal of the answer, you'd see that you actually did have the right answer. So paying attention to those units is really, really key. So how about you, Allie?
At first, I struggled even knowing where to start, but once you started walking through it, I was able to see like what I was supposed to be doing.
And that's, again, that's the goal in having these sessions is maybe it's a lot of coaching and facilitating as we do this, but then you feel a lot more confident and competent to kind of go and do some of these on your own, right?
Yeah.
Okay, very good. Any other questions on this guy? All right, let's move on to another one. And every single one of these problems is just like a different variation on things. This one is going to start bringing in some other pieces that are more science related, still not officially chemistry, but talking about density. So density was something we talked about in the first class. Remember that density is a relationship between mass and volume. And sometimes remember that volume can be given with something like cubic centimeters, and sometimes it can be given with volume units like milliliters and so forth. So density can have unique units, but this problem is telling us that we've got an empty Erlenmeyer flask. It tells us what it weighs. So one of the things that let me see, I'm going to look at my key here and see, let me show you the next page here, because sometimes drawing a picture can be really helpful. So we're going to have the same information here, but I'm going to show you, I drew a picture, right? So it says we've got an empty Erlenmeyer flask and it weighs 241.3 grams. Okay. When I fill it with water, okay, so I'm going to fill this all the way up with water. And now the flask weighs this much. Okay. So part A asks us to think about what the flask's volume is. So I can actually get the volume from that initial information. So it tells me that the density of that water that's in there is 1 gram per cubic centimeter. Okay, so I can do some unit conversions and part A can give me the volume of the flask. And then it's like, okay, now that I know the volume of the flask, so this is one of these problems that it does build. Okay, so this is an A-B that needs to be done consecutively. Now it says, how much would the flask weigh if I fill it with a more dense liquid like chloroform that has a density of 1.48 grams per cubic centimeter? So in this case, I want to know, what will that flask weigh? Okay, so I want you to try to work through this problem. Okay, I'll leave this on this page for just a second if you wanted to kind of have this picture to help you sort of think about things. And then I'm going to flip back to the first page that tells us the answers. Okay, so this might be the last problem that we have an opportunity to kind of work through tonight. I did have a few more problems. We might be able to do one more, but see if you can figure out the volume of the flask and then how much that flask would weigh if we put a different substance, a different liquid in there.
Just a quick question. Are we finding the volume with the water in it or without?
So that's a good question. So how this is working conceptually is think about when we figured out the volume like of the room that we were talking about in our problem before, we could just take length times width times height, right? Now this is the volume of something irregular. So oftentimes how they'll do this kind of in practice is they'll take and they'll fill up the volume of the container with water. And then remembering that if you know the mass of something, you'll know the volume. So I don't want to give away too much for this, but by figuring out how much water we put in, that can give us the volume of the flask. I don't know if that helps answer your question. All right, and it's just the two of you now. So, and I think you said ready for both, and Sarah, you said ready. So, these problems kind of it's almost like they're puzzles that we need to figure out. So let's kind of walk through. And I know, Sarah, I think it was you who had asked some questions, and I didn't want to say too much, sort of giving things away, but see if this logic makes sense. All right. So I've got this, I was looking to see if I had something around here that can simulate an Erlenmeyer flask, but I've got a picture here. Okay. I want to know the volume inside that flask. Now, it's not like volumes that we had before where I could take a length times width times height. But here's what I can do. I can fill this flask with water. Okay. So I'm going to walk through sort of the planning process for my calculations here. So if I fill it with water, and I know the volume of water that I put in there, then I'd know the volume of the flask. So one thing I guess I could do is I could pour, fill it up with water, and then I could take that flask and I could just maybe pour it into a graduated cylinder. But that's not going to be as exact as our next way. See if this makes sense. Now, if I fill this with water and then I weigh it again, I'm going to get the mass of water that I put in there. Okay. Now, if I know the mass of water, I don't want mass of water. I want volume of water. So again, anytime you're thinking about, I don't want this unit, I want that unit, think if you know a unit conversion that relates those two. I know the mass of something, but I wish I knew the volume. Relationship between mass and volume is density. Okay. So walking through sort of the thought process for the math, I fill this with water and I weigh it. If I take the difference between these two numbers, that tells me the mass of water. Now that I know the mass of water, I can use the density of water to walk to volume. Okay, so let's go through those calculations. And I was going to say, I think I have these on the same page. So let me walk through the logic then for the next piece, which is related, but just kind of going in a different sort of way. Now that I know the volume of this flask, I'm going to fill it with a different substance. Now I'm going to know the volume that I put in because I fill it up. Okay. And now it's like, well, what's that flask going to weigh? Well, I can still use, if I know the volume of the liquid that I put in, because it's the size of the flask, I can use the density of that substance to tell me the mass of the substance that I put in. Okay. And then I can figure out by adding that mass of substance to the mass of the flask, okay, that empty flask, I can get what this is total. Okay. So I'm going to pause for a second here. And I'm going to ask either Sarah or Courtney, I got to plug in my computer here. I'm going to ask either of you calculations. So one of the things that I always do is I have a roadmap. I have a thought process, a plan for my calculations. Do either of you have questions on sort of the plan, or does that make sense? Silence. Courtney, I'm going to call on you. Does that plan make sense? Is the logic? It's like, okay, that's kind of a puzzle that I can see the pieces to.
So yeah, I kind of understand it. It's just like, so I ended up getting the right answer for the volume, but I was confused like where to go after that.
Okay. Okay. So how about you, Sarah?
Yeah, so I got I wasn't sure again, like if I was doing it right, because my answers were right, but so I got the right volume for the original question. And then what I did was I just did 247.8 centimeters cubed times 1.48 grams over 1 centimeters cubed. And then I just added 241.3 grams onto that to get 608 grams. Is that right?
Yes, that's it. And so I'm going to flip to the next page and you'll see that's exactly what I did here. So here's sort of the picture of what's going on here. Okay. So on the left, I've got for part A, you basically take the difference between the flask being full and the flask being empty, its weight, and that's going to tell me the mass of the water. And then I can use the density to interconvert mass of volume to water of volume to volume of water. And then the volume of water equals the volume of the flask, right? So that's my plan. That's sort of I was talking about mentally with you guys, right? And then we've got the calculations of that, right? Here's the subtraction to get this piece. And then mathematically, we don't do anything here, but I will always have things that do nothing mathematically in there because they change the units. And so we get the volume of the flask that way. Now for the flip side, if I know the volume of the flask, that means I know the volume of the chloroform that I put in there because they're going to be equal. And now that I know the volume of chloroform, I can flask.
Your signal's
Get the
cutting out a
total mass of the
lot.
flask. So that's sorry. I think we sort of explained what was going on. I think my internet should be working here. Is it better now?
Yeah, that's better.
I don't know. I have to find out if the kids decided that it was time to go on to their video games when they know they cannot stream their stuff when I need to be in class. But I think your thought process was exactly right. Once we know the mass that we have of chloroform, then we can use the density to get, or then we can use the volume of the mass of the empty flask to add together. So I think, Sarah, everything that you said was right, but you're like, I don't know if that was right. There's actually not as many unit conversion pieces to this problem as there are kind of figuring out how to use the information. So Courtney, did you have any other questions on this one?
No, I think I'm good.
Okay. So again, a lot of these problems, I don't know, they're like little logic puzzles. It's like, all right, how do I figure out how to use these pieces of information? So you two are the only two that are left here, and you've been here with me kind of since the start. I'm happy to work through one more problem, but I'll leave it up to you guys. If you're spent and you're like, I don't want to do anymore, that's totally okay. Where are you guys at?
My brain is melting, but I feel like I just need to keep doing these because I feel like like I kind of get it, but I also get confused sometimes about just like how to put the pieces together. So like, I don't know, we can try.
Let's do, okay, I have two more problems here sort of on my plan of attack here, but let's just do the next one that's in line here. It you know, again, it's asking us, it's not chemistry problems, but it's asking us to think about maybe, remember I told you guys in class 2, there's 2 kinds of math that we're going to do. There's algebra / equations that we use, and then there's unit conversion. Okay, so this one that we just finished is kind of a combination of those 2. It's not necessarily equations per se, but it's kind of doing some regular math, some algebra, if you will, kind of determining like how do we figure out a piece of information that we don't know, and a little bit of unit conversion. So the next problem actually is going to do the same. So let's try this guy. So we've got a steel ball bearing. So think about a little ball bearing. I tell you what the circumference of it is, and I tell you what it weighs. So I want to know what's the density of this steel ball bearing in units of grams, and that should be a superscript, grams per cubic centimeter. So I give you an equation there that you need to figure out the volume of a sphere. It's 4/3 times pi times the radius cubed. Okay. And then the circumference of a circle is 2 times pi times the radius. So a couple of equations there that we're going to need to use to get some pieces of information to solve this problem. Okay, but there's the answer. So I'm going to give you guys probably about 10 minutes here to work on it. Since it's only the 2 of you, just unmute your mic and say either done or ready. And then we'll go through the solution.
I'm ready whenever.
Yeah, I'm ready.
All right, so ready doesn't mean done. So you guys got stuck?
Yeah.
Okay, so again, I'm going to show the solution to this, but I'm going to sort of zoom into the top part first to kind of show you the plan. So I always want to have a plan first, and then I don't want to start doing calculations until I have those pieces together. So I'm going to kind of zoom in first here. We see what we know what the prompt is, so I don't want to look at the answer. So here's my little sphere. Okay, so here's my little sphere that I have here. And so my little blue sphere has a circumference of 32.5 millimeters. So circumference is like the equator, it's all the way around. And I know that it weighs 4.20 grams. So the problem is asking me, what is the density? So we're going to see lots of problems throughout the course where it's like, it's going to ask me for an answer that maybe has two parts to it, because density is what's the mass of that sphere and what's the volume of that sphere. Well, one of these pieces is given directly. I actually know the mass of that sphere. It's 4.20 grams. So I'm not going to need to do anything to figure out the numerator of this problem. But I am going to need to do some work to figure out the volume of this, because all that they gave me was the circumference of this. Okay, so here's my roadmap here. I know the circumference in millimeters, and then they gave me an equation that can allow me to calculate my radius. So, and this is where that algebra piece comes in. I can solve for my radius by taking the circumference and divide by 2 times pi, right? And if you've got this calculator here, right, I can see that I've got a little button for pi right there. Okay, so make sure that you have a pi button on your calculator. So now I'm going to have the radius in millimeters, and I can use another piece of information that was given to me. I can find the volume of that little ball bearing by taking 4/3 times pi times the radius cubed. Now notice this is going to give me the volume of that sphere in cubic millimeters. Now I need to get to cubic centimeters, but I know a relationship between centimeters and millimeters. So one other thing that I meant to tell you in class today, but I forgot, is some everyday items that help you contextualize and think about sizes of things. I told you I wanted to think about a sugar cube. A sugar cube is about 1 cubic centimeter, and it's about 1 milliliter in volume. But another sort of everyday item I want you to think about is a dime, okay, 10 cents. So a dime, if you think about the thickness of a dime, that's 1 millimeter. So if you were to stack 10 dimes, one on top of one another, that would be about a centimeter. Okay, so that's another just way to think about, all right, it makes sense that a centimeter, which is a sugar cube, is about the same height as if I were to stack 10 dimes, one on top of one another. But this is my roadmap. This is my unit conversion and my calculations that are going to get me to the volume of that sphere in cubic centimeters. Once I have that piece, it just gets plugged into my density equation. And so that will be my denominator, and they gave me the numerator in my problem. Okay. So here's the roadmap put into action. So I'm going to take my 32.5 millimeters, that's my circumference, and I divide by 2 pi, because that will give me my radius. So here's my radius. Note what I do here. I keep lots of significant digits as I'm working along here. I do not round to the end. Now, in order to get my volume, it's 4/3 times pi times my radius cubed. I take all of those numbers and I make sure that they're in there. Okay, don't round too soon. Here's the volume of my sphere in terms of cubic millimeters. Now I can take this number. I know that 1 centimeter is 10 millimeters, but I need to cube this entire quantity, okay, which means that it's going to be 1,000 down there in the denominator. Okay, so I'm going to have this number of cubic centimeters, and I put this into this equation to give me density. Okay. Keep carrying things through in my calculator, and it's not till the very end that I'm going to round to 3 significant digits, and I end up with 7.25. Okay, and I'm going to just come up here to the top so we can see I've got 2 values that are sort of measured values that each have 3 significant figures. So that's why I have 3 significant figures in my answer. So you both said ready. So I want to wrap up here by just giving you an opportunity to share where you got stuck.
I didn't know how to use my calculator to do that algebra.
Got it. So did you figure it out sort of in the interim, or do you still need some help with that?
I'm at practice. There's lots of YouTube videos on how to do algebra on these calculators. So, yeah, but that's where I got stuck. I did follow the math. Like if I could have figured out how to do it on my calculator, I think I would have gotten the answer.
And and that's not an uncommon problem. So whether you in your own time try to figure it out offline, or that's certainly something, come visit during office hours, that's usually a quick fix to kind of help people navigate how to use their calculator. All right, so Courtney, how about you?
Mine was the same thing, trying to like work my calculator. Because when we went shopping, there was no Texas Instrument calculators.
Got it.
To get like a different one, but
I mean, most of the calculators will do it. I love this one because it is like dirt cheap. It's actually the one that my kids have to use for their 7th grade, like homework and stuff. So I've had them throughout the years here, but so I'm very proficient with it. But the fact that you could get it, I was like, when I had to get my 7th grader at Target for like $7, I'm like, I'm going to tell students, just order this online because it's super easy to use and it has all of that. So the good news is, I feel like the hard part is handled by you guys. You're like, I get the setup, I get how to do it, but we just need to make sure, and you are not alone in this. This is a very common problem, that everything that you have on paper is right, but then translating that to a numerical answer in your calculator sometimes has some hiccups. All right.
Yeah.
Anything else from you ladies before we sort of wrap up for the night?
I really still just want to go over my mistake of 19.
Oh yeah, yes. So let me stop sharing, and then
Okay.
Courtney, you're welcome to stick around, or if you wanted to bug off, that's totally fine. I'm going to try to take a look at Sarah's problem here and see if I can see what's going on. So Sarah, I'm going to make you, let me actually get rid of this guy here too.
If you can pull up your email, I actually emailed you my math, what it looks like on my paper.
Oh, okay, because I didn't see an attachment there. So let me look.
It's in the body of the email. I sent you a bunch of emails. I kind of had a mental breakdown in the library.
It's okay. So yeah, I was looking at the words here. So my logic led me to convert micrometers to millimeters using the knowledge that there are 1,000 micrometers in every millimeter, which is correct. So my math looked like 2.56 micrometers cubed times 1 millimeter over 1,000 micrometers cubed to get to. Okay, so let me just go back and look at. So I think that is right. Everything you have there is right. There's nothing that I'm seeing that's incorrect there.
Okay.
So, because I think when you were saying something to me in class, and it might have just been that I couldn't see your paper, but it seemed like there was something where you had something that had 10,000 with it, or 100, or there was something that wasn't 1,000.
No, that's basically my math. I just like logically, I didn't go like, oh, I'm going to go from micrometers to meter back to millimeter. I just went from micrometer to millimeter because they're right there next to each other. And that's kind of how I did that. And then like the way you did it, like I understand the way you did it, but then I was like, well, I don't know why the way I did it was wrong. And then that's why I had the breakdown in the library, and I was crying. I was like, I don't understand why I can't, like, I don't know why what I did was wrong.
No, and there's nothing that you did was wrong, but I think without seeing your work, it was a little bit of a challenge to make sure that there wasn't something that was missed. Grace had the same thing, I think, when we were working through some stuff today, right? And so let me just kind of pull this up because this summarizes it. Sometimes and you seem like you're one of these people too, you know this relationship between these different units. And most of them, when we get down here, are just 1,000, right?
Yeah. Yeah.
And sometimes people are like, I know the relationship between base to this. So, but it's harder for them to kind of go here to here. There was somebody in class today that actually was going from like micro to centi. And yes, it's a factor of 10,000, but I sort of had to like think about it for a minute to make sure it was right. So, you know, I think if you know these relationships, it's easy to not have to jump back to the base unit and then back down. So
Okay, so my logic was, it was logical. What I did was
it
logical.
is absolutely logical. Yep.
Okay,
Yep,
I was
totally
so
correct.
like, I kept looking at it and I was like, I don't know why, like there's an error in my thinking and I don't know what it is, but also like I'm pretty sick and I'm been taking cold meds, so it's making things a little bit harder than they normally are.
Well, glad it wasn't, because I know you were worried that because you had been exposed and all of that. So glad to see that it's just, and there are some nasty colds going around. And I know it's hard when you're trying to feel like, oh my gosh, is this just a cold or is this something?
I know. I'm glad I got tested because I'm pretty, like I am pretty sick, but it's just a normal horrible cold and not COVID, but it's also not making, like I'm not a math person, so
well,
this is hard for me.
No, what you're doing very well. So what, and hopefully once you get past the head cold piece, it'll be even better. So you're all good.
Okay, I'm so relieved because I was so confused about what I did wrong.
Nope, you're all good. You're all good.
Okay, right. I feel like I got this like 95%, like good. 95%, maybe. Like we'll see how I do on the test.
Well, the good news is that, like I said, there's lots of opportunity for, you know, trying it again, because this, and that's why I do this with these quizzes. Like each unit has some critical key thing that it's like, gosh, like I need to know that you've mastered this, because it's going to be something we'll see again.
Yeah, is there, just in case, like I can't take the recitation because it conflicts with the required class, but is there tutoring available if I need it?
Yes, there should be. I actually asked a number of my students if any of them were tutoring, and I was surprised that a lot of them weren't. But they usually don't do anything with tutoring until like after we get a couple weeks into the semester, only to let the tutors sort of get their feet under themselves with their own classes and all of that. And I think I usually have on Blackboard, I'll have to find where I hid the link. I usually have a link to be able to go and sign up for and request a tutor, which the sooner you can do that, the better. Because unfortunately what sometimes happens is there's this flurry of activity like 3 days before an exam. And then students often aren't able to get in.
Okay, so there's a link on Blackboard I should be able to find.
It's not there right now. I have
to
find where it's, because when I copy stuff over for my classes, I don't necessarily make everything live all again at the same time. So I'll have to find the link, but I will get it posted.
Okay, because I would definitely love to get hooked up with a tutor for study site. It's been 15 years since I've done algebra, so
you'd be surprised how quickly you can sort of dust off those cobwebs and get back on that bike. So I think you're going to be just fine.
Okay, the only other thing is my link, my original invite to Teams does not work. Every time I click on it, it says it's a broken link.
Let me try this again. So you're saying for the class, right? So let me go to my, see who my members and guests are.
Like the invite I have says there's literally only one person in the group, and also I can't join it.
So what I might just do here is I'm going to just delete you and try to add you again. So let's try this. So I'm going to add you. And this is Sarah Spells, right?
Yep.
And so it's SSELL 34. Is that right?
SSELL TELL34.
Yep, yep. Okay. So I just added you. So, and I see you again here. So why don't you see if you can go, are you able to go onto Teams and see other things?
Oh, it's still saying, it says team channel unavailable. Something went wrong. Please try again later. That's what it always tells me. Every time I click on that link, I don't know why. Like I have Teams downloaded. I can use Teams to make my own groups, but it doesn't let me,
So let me just try, why don't you, let me try sending you just like a chat message. And see if that works. So I just sent a test message through Teams.
no, it doesn't work. I don't know. Maybe we just need to sit down together and figure this out. I don't know why it's not working for me.
And do you have other classes that are using Teams at all?
No, you're the only one.
So, and it could be, yeah. Let's maybe, if you know, one suggestion might be, do you have an Android or an iPhone?
I have an iPhone.
My phone's about to die here. What version of like iOS software do you have? Do you know?
Let me see. 14.6.
Oh, that should be that, like you're certainly, it's not like you have an old iPhone. Maybe try deleting the app and reinstalling it.
Okay, I will, because every time I click on it, it just says there was an error, you know,
Yeah.
so, but it doesn't know what error, it says unknown error. Okay, I'll do that.
Okay.
And then I'll retry everything again. And if it still doesn't work, I'll touch base with you tomorrow through email.
Sounds good.
Okay, thank you
All
so
right.
much for all your
You're
help
welcome.
tonight.
You're welcome. Have a good night.
You too, bye.
Bye.